Hello there. In this video, we're going to look at solving a system of linear equations. In the previous video, we looked at it through a graphing perspective. So graphing and looking for the intersection. And we want to recall really quickly, when we graph a system of linear equations, we could end up with one intersection, which is typical for lines. If they intersect, they're going to intersect at one point. And I should say, if two distinct lines intersect, they will intersect at one point. We could have parallel lines, which means we would have no solution whatsoever, or we could have effectively two equations that amount to the same line, which would be infinitely many solutions. In this video, we're going to go over the substitution method, and as you watch this video, you're going to notice that the equations I'm using are the exact same equations in the previous graphing video. This is simply because we know these solutions already. We can save time without having to check our work and just get the basic properties down, or I should say basic procedure down, okay? Now I'm gonna start with the second example from the last video because I think this is the optimal situation in which to use a substitution method. The reason why is because we have a variable in equation. In this case, it's y. It doesn't have to be y, it could be x. We have y by itself with a coefficient of 1 on one side of the equation. We can take this and plug it in for y here. So I'm going to go ahead and rewrite this equation, negative 8x plus 2, but instead of writing y, I'm going to write this part right here, 4x plus 1. This is what substitution is. Substitution is removing something and replacing it with something else that is of equal value. All right, now we just need to do a little algebra. This is solving an equation. And notice all we're doing now is we're solving for x, okay? Once we get x, we'll plug that back into one of our equations and get y for our final solution. Okay, so I'll go ahead and distribute. I get negative 8x plus 2 times 4 is 8, and then we get the x. 2 times 1 is 2. Equals 2. Now, a couple things I like to do. Usually I like to eliminate the variable or combine the variables first and then move the constant over to the other side. So that would be subtracting 2 here, and this would cancel, but also this cancels. So I'm just left with 0 on the one side, but also when we combine our x's, I'm adding opposites together. So that also will cancel, and I'm left with 0 equals 0. This fits. If you watched my graphing video, then we had in this problem the same line that we graphed. So this is an example of what you would see when you get infinitely many solutions. And how do we know this? Well, simply we don't have a variable to solve for. And when you lose your variable that you're solving for, and you are left with a number equals a number, one of two things is going to happen. One, it's going to be a true statement. In this case, that's what happens. 0 is equal to 0. Okay, great. That's a true statement. That means there's infinitely many solutions. But let's say we got something like 0 equals 2. Well, that's, of course, ridiculous and not true. So this would be a case where we have no solution. So something to keep in mind. All right, let's talk about the second example. In this case, we have two equations with y by itself. Now, this is okay because we have y, and we can still take this and substitute it in for this y here. So if I take the 1/5 x minus 4 to substitute it in for y, we set it equal to negative 1/5 x minus 6. And this is a pretty standard equation. I'm going to go ahead and add 4 to both sides. Okay. And I get 1/5 x equals negative 1/5 x. This will cancel. Minus 2. And actually, I'm going to get rid of the fractions now so I don't have to deal with them. Let's multiply by 5. And so we get 5 times 1/5 is just the x. 5 times the negative 1/5 gives you negative x, and then 5 times the 2 gives you minus 10. Now I feel a little bit more comfortable adding x to both sides. We get 2x here. This will cancel out, and I get negative 10. Then once I divide by 2, I get x equals negative 5. which matches our solution. Let's go ahead and plug that back into here. So y equals 1/5, and I'll plug in that -5 minus 4. Okay, so the 5's cancel, and I'm just left with a -1 minus 4, and I'm left with -5. So my solution is -5, -5. Now, if we're being thorough, we would also want to plug x back into here and see if we get the same x value. But there's no reason why we shouldn't, as long as we've done our math correctly. Okay, let's do the last example. Two equations that are in standard form. Let's go ahead and move one of them to get a variable by itself. Now, you can do the first one, y looks like a prime candidate, or you can do the second one, x looks like a prime candidate. This y has got the negative though, so I'm going to go ahead and work with this first one. I'm subtract 3x from both sides, and I get x equals -3x minus 23. Plus, it goes to show you it doesn't matter if it's x or y. So I'll go ahead and take that and plug that back in here. So I get 5, and instead of writing the x, I'm going to write this equation or expression instead. So -3x minus 23. Okay, and then write the rest of it. Minus y. Or, sorry, that should be y, not an x. Let me fix that. And now we've got what we had in the last problem. Let's go ahead and distribute our 5. 5 times -3 is -15. 5 times -23, that is -115. -3. Let's go ahead and -15 minus y, that's -16y. And then we'll add our 115 to both sides. 115, and we get equal to 112. And let's go ahead and just do long division. I know that 16 is divided by 4 actually, and so is 112. So I get -4 y equals, so 112 divided by 4. I get 2, that's 8, 3, 2, 8. So 28. So 28, and then divided by 4 again, we get, well, -4 this time, we get -7. Let's go ahead and plug that back. Now, the goal when you do substitution is plug it back into the equation that was the equation you had the solitary variable. So here we'll go x equals -3y. And we'll plug in our 7 for y. Okay. And then minus 23. -3 times -7, that's 21. Minus 23 is -2. So our final answer is -2, -7. Again, if you're feeling thorough, plug these numbers into this equation and solve. Thanks for watching this video. If you want to see other videos in the future, leave a comment down in the comment section. Also, tell me which method do you prefer more. Do you prefer graphing or do you prefer substitution? Thanks for watching, and I'll see you for the next video. Bye.